We're gonna start this by analyzing problem number 24 from lab procedure. So it's this one. We're gonna be evaluating for the limit when x tends to 1 from the positive side for this expression. So the first thing we've got to recognize here is that we're evaluating for the positive side. This meaning that we could evaluate for this by substituting a number that's greater than 1. In this, we could use, for example, 1.1 easily by substituting on the bottom null expression. So if we substitute this, or if you're doing it in the calculator, it's gonna equal 52. And well, we could use another number as well, for example 1.01, and if we do the same substitution, we can realize that we're gonna get a number kind of similar to this one, just with one more zero, and the same goes on with like more numbers. So these numbers are proving to us that from the positive side on this expression, the limit is gonna be facing the positive infinity. So the limit for this expression is gonna be positive infinity. So this is a second problem we're gonna be doing. It's lab procedure number 64, which is this one. They're asking us to differentiate the problem. So in this case, I started off by first just taking this separate expression and rearranging it over here, and continue in this procedural section. The first thing I did was took 6 here, multiply times dx, and I got the cubic root of x. Since it is on the numerator, it's going to be equal to 1. It has a value of 1, like 1 whole, and then I took the 8, multiplied times the out of the x, and then I took the expression u and expressed it as 1 out of that expression, and then I head over with the 2, put it here, then times dx, then I multiply it times this here, and a 1 on the numerator. The next thing I did was just this expression is going to be equal to x out to the power of 1/3, which is here. So you multiply the 1/3 times x, and then times to the power of 1/3 minus 1, and you just put the 5 there. Here it's basically the same thing. You take out the 8, you multiply it by 1/4, which is the equivalent of this expression simplified, and the power is going to be negative 1/4 minus 1, and here you're going to take the 2, multiply it by negative 3/2 from the expression over here. So you're going to power up that to negative 3/2, same as over here and in here, and you're just going to subtract 1 to end up with a result of negative 2 out of 5x to the 3/2 minus 2x for 5/4 minus 3 of x to the 5 out of 2 x.